Okay, so we've got here four horizontal forces, so it's all happening on the ground in one plane, as you can see here in these directions, and we're asked to find the magnitude of the resultant of the forces and determine the acceleration. So before we, first step here is to resolve the forces in a cross format. Okay, so we've got our x and y direction forces resolved in all four directions here. So let's do that. So with the 8, it's got the angle contained here with this side, so that'll be 8 cos 30 and 8 sine 30 then opposing it. As a result then it's going this way. The 12 newtons containing the angle here, so that'll be 12 cos 50, 12 sine 50. 7 newtons then go in this direction, so containing this angle here is this side, so that'll be 7 cos 45, 7 sine 45 in the y direction, and then the 15 then containing the angle on this side, so that's 15 cos 60, and then 15 sine 60 here. So a lot of forces, but we can rely on our calculator to work this all out for us. Okay, so if we then resolve in the x direction to start with, so we take this as positive, so we got 8 cos 30 plus 7 cos 45, take away then these two combined, so 12 cos 50, so we take away both of them, right? So we take away the 15 cos 60 as well. So we work that out. Let's just do that on a calculator. So we just type it all in. Okay. So we've got 8 cos 30 plus 7 cos 45, take away 12 cos 50, take away 15 cos 60, and we get out negative 3.3355. Okay, so they want the answer to be one decimal place at the end, so but we round at the end. There's quite a few decimal places here. Okay, to start with, maybe we could have 5 and then there'll be 0 there. Now it's negative, which means actually the overall winner here is this direction, so it will actually shift this way. But let's then resolve in the y direction. So we've got 12 sine 50 plus 8 sine 30. Take away then the opposing force 7 sine 45, and take away the other opposing force 15 sine 60. So I work that out. 12 sine 50 plus 8 sine 30 minus 7 sine 45 minus 15 sine 60. So if I do all that, it comes out then to be minus 4.747595. Okay, so we put 6 decimal places there maybe. Okay, and that's negative as well. So you can see now it's going this direction and this direction. Okay, so overall we've got the resultant force going about that way there. Okay, so when I establish that, they want the magnitude, remember, of the resultant force. So we just need to appreciate now, because it's negative, it's going this way, 3.33550, and it's going this way, 4.747595, and of course then the overall resultant effect is essentially that direction there, yeah? So we can work out the resultant by doing Pythagoras. So of course we are going this way as we discussed, and then we go in this way. So we've got 3.33550 and then 4.747595, and the resultant effect then is this direction here as a combination of going this way and this way. So Pythagoras then would say R is square root of this squared, add then this squared, and then of course square rooted. So my calculator, if I type that in, and I get 5 point, no, they wanted one decimal place, didn't they? So 5.80, so 5.8 newtons would be the resultant force. It then says determine the magnitude of the acceleration. Well, we know that's the resultant force, so we just apply then Newton's second law. Okay, so F equals ma. So we know the resultant force is 5.8. We know the mass is 4 because it describes that it explains that in the question, and then we've got the acceleration then, which we're going to work out. So that means then the acceleration is 5.8 divided by 4. Okay, so we get 1.45 meters per second squared.